formula used for this experiment is R equal to L1 minus L2 whole multiplied by R and divided by L2, where L1 and L2 are the balancing lengths without shunt and with shunt respectively. A Daniell cell is used as the primary cell whose internal resistance is to be found. R is the shunt resistance in parallel with a given cell. First of all, tight connections according to the circuit diagram. The EMF of the battery and that of the primary cell are measured, and it is made sure that the EMF of the battery is greater than the EMF of the primary cell. The positive pole of the battery is connected to the zero end of the potentiometer and negative pole through a one-way key, an ammeter, and a low resistance rheostat to the other end of the potentiometer. The positive pole of the primary cell is connected to the zero end of the potentiometer and negative pole through a galvanometer to the jockey. A resistance box of small range is used as shunt resistance through a one-way key K2 in parallel with the primary cell. The plug-in one-way key K1 is inserted and the ammeter reading is noted. The jockey is pressed at zero end and the direction of the deflection in the galvanometer is noted. The jockey is pressed at other end. If the direction of the deflection in the galvanometer is opposite to the first case, then connections are correct. Without inserting the plug in the key K2, the rheostat is adjusted and kept fixed for constant EMF. The jockey is gently slided over the potentiometer wires till a point of no deflection is obtained on the galvanometer. The null point position is obtained accurately and the balancing length L1 for the EMF of the primary cell is noted. The shunt resistance is connected by inserting the plug into another one-way key K2. Adjustment is made from the resistance box connected in parallel with the cell. The jockey is gently slided over the potentiometer wires till a point where galvanometer shows no deflection is obtained. The null point position is accurately obtained and the balancing length L2 noted. Knowing L1 and L2, the value of internal resistance of the given primary cell can be measured.